Welcome to Catchpoint 6 Live Ask Me Anything on WebAssembly, presented in partnership with the W3C and O'Reilly Media. My name is Robert Casson. I will be your moderator today. And a little brief intro about me. I am a senior performance engineer here at Catchpoint, and I've been here for just over 3.5 years, but I've actually been in the synthetic and real user monitoring space for about 10 years. And a little fun fact about me is about, a long time ago, I wrote a little content management system called Mambo. And today it lives on as Joomla. There we go. So we have a few housekeeping notes before we kick off the AMA. All attendee lines are muted, and the presentation is being recorded and will be sent out over the next couple of business days. So feel free to use the Q&A feature in Zoom, and time permitting, we'll be able to answer a few. Let me start off today by introducing today's panelists. First, we have Brad Nelson. Brad leads a skillful band of Mountain View and San Francisco Googlers working to enable more things to run performantly on the web. He currently chairs the WebAssembly working group. His passions include tiny programs, colorful pictures, and the fourth programming language. A fun fact about Brad is that he once played Bob the Sheep in a play called Revenge of the Space Pandas. Great to have you here today, Brad.
Thank you. Glad to be here.
So next up, we have Luke Wagner. Luke Wagner is a software engineer and has worked on Firefox JavaScript engine for the past 8 years. Luke co-invented asm.Js in 2013 and then helped kick off WebAssembly standardization a few years later. Luke now works on Firefox WebAssembly implementation and the evolution of the WebAssembly standard. Now, Luke, his first few years of programming were writing GoTo riddled TI basic. After that, he randomly bought Learn C in 21 days and promptly failed to do so. So thrilled to have you here today, Luke.
Thank you for having me.
You're more than welcome. And last, but certainly not least, we have Eric Prud'hommeaux. Eric has been at the W3C for some 20 years. He has worked on protocols like HTTP and HTTP extensions, then started the web services work, and finally gravitated to the semantic web, which he applies to life sciences and clinical data. A fun fact about Eric, he's not really French, but he lives in France and has the Frenchiest last name, so of course everybody starts speaking to him in full tilt French. Thanks for joining, Eric.
Merci.
Durian. Also on the line, we have some incredible WebAssembly experts who will be contributing their WebAssembly knowledge and expertise to the chat discussion. Our in-chat experts today are Mozilla's Alon Zakai and Dan Callahan, Google's Ben Smith, Deepti Gandluri and Heejin An, and Ashley Williams from npm.js, Jay Phelps from Netflix, and Kenneth Christensen. Thanks all for joining. So great, we have some fantastic user-submitted questions. We only have 54 minutes left, so let's dive straight in. Now, the first question is to be for Brad, but it should really be for Eric. What is the raison d'etre for WebAssembly?
Well, I'll tell you what I think, and I suppose we all have slightly different views on this. But we actually recently wordsmithed this on our team and said, oh, it's to enable more things to run performantly on the web. But the way I think of it personally is this is about unlocking access to the machine and bringing more applications. So this is going to allow us to bring applications that previously only made sense on desktop and mobile to the web. And this will allow us to bring more programming language to the web, so that you'll be able to use a broader range of languages than just JavaScript. And I think it's an opportunity to be able to polyfill and prototype web APIs as they're developed. So a sort of prototype version of an API might be implemented in WebAssembly and then eventually baked into the browser.
Would anybody else like to chip in?
It's a beautiful answer. Totally agreed.
Yep.
Okay, look at you go. Okay, so the next question is for Luke this time. How can web developers start using WebAssembly now with JavaScript in their current build processes?
Yeah, well, there's a number of ways and growing. So, the most common that we see most people using is Emscripten, a high quality tool that compiles C++ to originally asm.Js and now WebAssembly. And it helps take all of your, if you have a portable C++ application, helps bring it over. And if you look at emscripten.org, it has a lot of, a number of ways to call JavaScript from your C++ and to export your C++ functions to JavaScript. There's a growing number of languages that tend to have script in the name. I was just looking at assembly script that generates WebAssembly. And last, and kind of very exciting, because I'm talking to a lot of people about it this week, is Rust is becoming a new option that generates WebAssembly, and that's gotten a lot of excitement. And what's exciting is it's not just bringing Rust to WebAssembly, but also designing to fit into kind of the ES module workflows that a lot of developers are already using. So using the bundlers and tools like NPM. And with Rust, then to call some JS, you would import it like an ES module, or to call some Rust from JavaScript, you would import the Rust with an import statement. So lots of ways and growing, and I think improving over time.
Cool. Thank you very much, Luke. So, Eric, once WebAssembly is released, every programming language will have to compile to WebAssembly. Wouldn't it be more interesting creating a new intermediate language over WebAssembly common to all programming languages so that they can compile to the intermediate language instead of WebAssembly?
Well, I feel like that kind of misses the ultimate point that WebAssembly is that language, right? So there's the notion of I have a low-level virtual machine. You could think of it like a Java virtual machine or an i86 virtual machine that you're running on something else, and then you've got languages that you compile to that, like C or whatever you could in fact compile your JavaScript to run on that as well. And so it feels to me like almost a problem in search, a solution in search of a problem. It could be that we look in the fullness of time, we look at WebAssembly and say, well, now that we've got this, now that we really understand what this virtual machine does, we can imagine a sort of a specially tuned language that could make good use of that, like Java makes good use of the Java virtual machine by virtue of taking advantage of its string functions for class identification. But my guess is that would be a good ways down the road.
I'd certainly like to add, I think one of the things we've strived very hard with WebAssembly to do is to make it a good compilation target for a range of languages. We've tried to think about it as something that's that many different languages can target. It certainly has, especially the first iteration of it, sort of a low-level C++ kind of skew to it. There are folks that have, in our tool chain already, a tool called Binarian sort of sits in between, and you can target that abstraction instead. And my hope is that folks that want a slightly higher level abstraction can build that on top, that we can sort of be that right low level layer to sit right in between the program and the machine.
Okay. Sorry, did somebody else want to say something?
Oh, no, I was just adding, yes, I was agreeing with Brad.
Fantastic. Nice to see you all getting on. So, Brad, what's the current state regarding DOM access through WASM, and what are the technical difficulties with this?
So just for context for folks that may be unaware, right now WebAssembly programs at least in the web, live their life in a sea of JavaScript, and they're allowed to import functions from JavaScript and then export some functions to JavaScript. But those functions have to operate just on basic types in 32s and float 32s and 64s. And if you want to do something more complex, you have to do a lot of work in the JavaScript around the program to sort of marshal data in and out. Now, the Emscripten toolchain provides a lot of facilities to automate this. But there is this notion that we might like the WebAssembly module to be able to more directly manipulate JavaScript web and DOM objects. And we've actually recently started calling this host bindings because we even want to be potentially agnostic of the web itself. And so just whatever the host of WebAssembly happens to be. The proposals that we have actually a couple of different variations on a proposal iterating at this point. My hope is that we'll actually make fast progress this year. I know Luke is very enthusiastic about this direction, as am I. It opens a number of different possible directions. One is that we can actually be much more efficient. If we know the types that are flowing in and out, we can maybe punch over, several layers of disintermediation in between you and low-level APIs in the browser. But we can also improve the ergonomics of WebAssembly so that a WebAssembly module can sort of look like some more arbitrary piece of content, can be a better polyfill for web APIs. So the proposals are very early stage. There's sort of, even just in the last month or so, there's been some ideas about carving off parts of the managed language proposal and sprinkling that in. So while on the one hand, sort of everything is on the drawing board at the moment, my hope is that we can move very quickly on this.
Okay, thank you very much. So Luke and Eric, while lots of people are eager for direct DOM access from WebAssembly, I'm interested in maintaining the import sandbox by default. Will any future direct access features also retain the ability to prevent such access?
Right. Do you want to go, Eric?
I was just going to warn people that in the future their checkbooks will be laid bare on the web. No, actually, I think security is of paramount interest to all the web vendors, the web browser vendors. But Luke probably has more details for that.
Yeah, and even within the obvious security sandbox of the web, there's multiple kind of levels of isolation. And what's good here is that WebAssembly has a very strong form of isolation in which it can't reach out and just grab something. It can't poke a hole through the browser. It can only call what it's given. And so it does this through the imports object. And that's the case today. WebAssembly can only call out what it's been given in the imports object. And when we talk about these host bindings, which Brad was just talking about, and we're quite excited about, they fit within that model. They're still calling through imports. We're just basically giving them a richer set of types to pass to those imports and a more efficient path when they call those imports to get straight into the browser. But it's still going through that import. So if you want to, say, delete a function from like a global object, and because you don't want anyone else to call it, WebAssembly won't be able to magically materialize that. Or if you want to monkey patch it and say, don't call that, call this thing that fixes a bug in this particular browser, well, then you would get the monkey patch version also. So in that respect, it kind of maintains the strong sort of object capabilities in some parlance that people hope for.
And I should say this, at our last community group meeting, we had someone who, actually from my team, Mark Miller, who cares very passionately about preserving this property, and we're actually trying to wordsmith sort of just the right phrasing to capture the property we're trying to preserve. I do actually wonder, as we explore interoperability with ES6 modules, if there's a potential chink in the armor there, because there the module is allowed to express its list of imports and then potentially reach out and touch those. So I worry that might be one place where we'll have to be careful that that if the root thing being loaded is a WASM module and it's allowed to pull in arbitrary dependencies, then we sort of slip into the model that we have for JavaScript, where things are a little more open. Curious if you have thoughts on that, Luke.
Yeah, it's funny. We were just talking about that today with Yehuda Katz of Ember. And I think what we can have is defaults that have good ergonomics. They just pluck things from standard places. They would still pick up whatever you've left there. If you've monkey patched a thing, it would still just be doing basically a sequence of get props, like a default sequence of get props that's, oh, well, if you ask for this function, it'll pull it off of, the appropriate prototype on the DOM, object or whatever. But then I think there should be ways of kind of disabling that by default and saying, no, don't provide access, only what I give you. And it's not exactly precisely clear what the proposal is, but I think both something that, so everyone doesn't have to always make this kind of goofy JavaScript shim that like pulls a bunch of things from prototypes and puts them in a big imports object. We can say, okay, well, let's say as if you wrote that, let's have a default, but be able to turn off that default or override it or tweak it.
It is probably something that in that space we want to be thoughtful about, because it would be a shame if we get into a pattern where people commonly have modules that they depend on third-party modules that they don't control, and those expect a pattern in which they need access to all the global things. Then you're kind of in this situation where you're sort of obliged to trust them. So it would be nice to be able to make a stronger assertion and keep that nice property we have now, even in that modules world.
Yeah.
So no rest for you, Luke, I'm afraid. So now that the big four, Google, Apple, Microsoft, and Mozilla, have all shipped browsers that support WebAssembly, are these companies going to increase their investment in WebAssembly to grow adoption, development support, etc.?
So definitely can't speak for anyone's intentions, but what we can say is at the beginning of the whole WebAssembly process, we all kind of agreed that there's this model of ship an MVP and then iterate, and that's kind of one of the big reasons we were actually able to ship something in 4 browsers in only 2.5 years. And so the big question is, of course, will we follow through? We did the MVP, will we now iterate? And from all I can see, and what anyone can see in, like, if they attend community group meetings or working group meetings, is all the browsers are actively engaged in discussions and participation in this. And at least for our part, Mozilla, we fully intend to keep this going and realize the full potential of WebAssembly, which involves just definitely adding some more of these web interop features, these GC features, and just a list of other things that we've been talking about.
Again, speaking just for Google, but I mean, certainly we fully intend to continue this collaboration. That our first version was, is really just the starting point to build on all of these additional powerful capabilities. And yeah, we're excited how quickly the things have progressed and how engaged everyone continues to be. Beyond investment directly in WebAssembly, there's obviously folks at Google in various capacities that want to make use of WebAssembly. Google has a range of different properties. At Chrome Dev Summit, we recently showed off a version of Google Earth that we're working towards rolling out using WebAssembly. Our codec team with Chrome is interested in using WebAssembly in a range of different ways. Possibly that'll find its way onto YouTube for video codecs there. And we've already rolled out that same team actually has rolled out a 3D model decompressor called Draco that uses WebAssembly. And that's used in Three.js, and we collaborated recently with NASA on a WebVR demo that uses that. The Google Keep and Ink team are exploring switching over to WebAssembly in a bunch of contexts where they have styluses and whatnot. And just I've heard rumblings from all parts of the company. Everybody wants to figure out if this is a performance win for them and where they can best make use of it. So obviously, one thing we also care about and are going to try to put some energy into this year is making the developer experience better. And so we've been already planning for next year and talked about doing that. So.
Excellent, thank you very much. Monsieur Prud'hommeaux, I love the... Bonsoir. I only know about 5 words in French, so we'll just use those for the rest of the evening. So I love the ECMAScript TC39 proposal status page, progress stages, and yearly releases. Are there any chance of repeating this workflow for WebAssembly?
So yeah, in short, yes. The standards work is really all about wrangling people's energy and enthusiasm and getting them to discover that they actually agree on stuff. And so one of the things that's critical to that is getting the tooling there so that people don't feel like they're part of like a fax network, and that they're actually getting the steepest learning curve and the fastest communication they can have. So W3 process has a bunch of rules around how we make sure that we have met the community's expectations, that we've reached them, we've invited the community and invited their feedback, and then met their expectations. Apart from that, the groups can do whatever they want. So that's the more people, if you love ECMAScript TC39 process, then I love ECMAScript TC39 process. So more people who bring us good ideas, the better. I think the recent shift to GitHub issues and stuff like that shows that people are extremely agile when it comes to how they're going to do business. And we've come a long way from working in Word files.
Yeah, just for context for folks, I mean, a bunch of us had previously engaged with the ECMA TC39 process, and in fact with WebAssembly we have this actually phases 0 through 5 that was at least loosely inspired by the stages in TC39. We of course wanting to learn from mistakes there, tried to decompose that into an even more fine-grained set of steps in which there's clear entrance and exit criterion. We do have I'll paste this into the chat, but we do actually have a view of our issue tracker that highlights the standards in progress. One of the things that's sort of missing from that is that we haven't been extremely precise in targeting, labeling the different proposals and their phases, partially because I think some of them predate when we had set the phases in stone, and also I think for some of them the sort of strict phase that they're at it doesn't sort of accurately capture how far along they are. We're missing one thing or another for each of them. But I do like how pretty the proposal one is on TC39, and I think we did have some passing discussion about maybe scripting something to pull out these issues. One thing that we do have going for us is that generally speaking, with each of our proposals, we've tended to select an emoji to stand for that particular proposal, and so seeing that all together in one place would probably be a nice looking thing.
Thank you very much. So Brad, to kick off this one, but all three of you, you can all have a go answering this one, but will web browsers include a WebAssembly console, compiler, debugger tools, etc. for developers?
For those of you who've experienced our debugging and developer tools story right now, obviously it's been a mixed bag. In Chrome at least, we offer the fairly limited facility to allow you to go and look at what we call linear disassembly of the WebAssembly module. This isn't typically what you want if you're coming from C++ source, but it does mean that you can go in and see what's running. It's not just a complete black box, although you do have to make sense of the WebAssembly instructions. We've agreed in our tooling conventions on an extension to source maps that applies to WebAssembly, and our good friends at Mozilla have successfully implemented this in their browser, and we're striving to provide this soon in Chrome. In 2018, I actually hope to push the needle even farther to be able to offer an even better developer experience. We've talked at past CG meetings and here internally a good bit about the idea of being able to provide sort of full debugging information. Perhaps either the phrase web dwarf has been put out there, or another path is some sort of a layered service providing layer on top of some of the existing debugging protocols, where individual languages would be able to provide their description of how you debug for their particular language. I'm hopeful that we can make some progress on that front this year. Certainly I've had conversations with our DevTools team. In terms of in-browser interaction, there's a great demo that someone from Mozilla has produced that allows you to do this interactive compilation of a program and see the result. It's WebAssembly Explorer, I believe, is the name of it. Certainly there's all kinds of interesting explorations of developer tools going on, and I hope to see more and more in that space.
Yeah, and just to add on to that, and to talk about what's currently that we've just kind of recently finished adding to Firefox Nightly is you can step into WASM code, and if that WASM has an associated source map, you'll just see, your C code in exactly the same place you would see JavaScript. You can place a breakpoint that's mapped back to the underlying WASM code. And unfortunately, at the moment, what you'll see in the locals window is the raw WASM locals, but we're talking about an actually old extension that was proposed to source maps that would be generally useful to JavaScript, which lets you establish a concept of scopes that kind of are scopes from the source language that map to the underlying compiled JS that you pop out of, say, Babel or something. And this could, of course, be useful to WASM because what you wrote in your source language has probably been scrambled to a million different locations into registers and such in WASM. So that when you start to add that, then we can still, some source maps have some limitations, but you'll be able to at least kind of basically step through your source code and see kind of basically what's in local variables, and that's something to go on. But I agree with Brad that we ultimately want to do something much, much better, something that feels first class, like I'm actually debugging this language for sure. And it's still an open question of how precisely to go about doing that. But for the moment, we're just trying to polish just that basic workflow that's using source maps. And if you don't have source maps, they'll show you the kind of the raw assembly and make sure even that has the things that you might expect, like you get from Visual Studio, like let me look at linear memory, what's on the operand stack, kind of basic machine level stuff like that.
Is there any cap to that? Like what keeps us from having something that is, I don't know, if you're instead, so I guess analogous to how it works right now is kind of like if you were looking at the base pointer and saying 2 up from the base pointer is this variable and 5 up from the base pointer is that variable. And is there a practical cap on how deep into the source language we could make the source maps in order to make the debugging be as native as possible?
Well, in the limit, you get dwarf, which involves full general computation that lets you arbitrarily, with like a full expressions, compute. If you want to see this, well, you have to take this register and add this value and then dereference that and go here. And so that's definitely, to push source maps all the way so that it feels first class is basically the web dwarf. And that's one direction. The other one is to say, now let's just let people write code and give them machine access. Let them basically write their own headless GDB server. There's a lot of ways to think about it. And, both have their pros and cons. And so we'll have to experiment more to figure out what's the right way to go.
Yeah. One of the things that I find exciting about the direction of having it be a program rather than trying to have the sort of one debugging format to rule them all is that if you imagine languages beyond C++, various interpreters, there would be the opportunity to have that layer communicate with the runtime of those languages. And so imagine you're debugging Python and you might want to actually interact with the innards of the Python interpreter. You're not going to necessarily want to have to statically capture all of the information you need in some file format. On the other hand, dwarf is extremely efficient in terms of its size and sort of what it gives you for the size. So possibilities we should definitely explore.
Okay, so this one, I'm looking forward to this one, and you are limited to 1 each. You can only respond with 1 answer each. And that is what is, in your humble opinion, individually, the most exciting use case for WebAssembly that is being used now or explored?
Well, I have my favorite. I was approached by a fellow from a company called Scava, who is producing tools for shopping, and they actually have a prototype of a barcode scanner that they've done using WebAssembly and the camera API. And they had actually previously approached folks at Google and others about, could we get a web API for barcode scanning? And of course, web APIs take a long time and whatnot. And so, in the past, this would have been a multi-year effort to have any kind of a path to have a coherent barcode scanning API. And with WebAssembly, this company was able to just go and create their own. They didn't have to wait for the web to catch up and provide this. They could take some existing libraries for barcode scanning, compile them with WebAssembly, use the existing camera facilities, obviously, in the browser to get access. So that one was just out of the blue and exciting.
Cool. I thought you were going to go down the Space Panda route, but you didn't.
If I could follow up on that one.
Yeah, sure.
I think that one of the opportunities that we see here is that people get to develop a sort of decentralized standardization where people get to develop their APIs, but without having to go through the browser vendors. And that means that codecs and barcode scanners and stuff like that can develop much more quickly. And I feel like I don't have an exciting, socially, my exciting use case is the general case of being able to develop these APIs in a decentralized fashion.
Yeah, my answer actually was not coincidentally in the same theme as these, which is ogv.js, which is used by Wikipedia. So, you know, Og Theora of Orbis, nice open codecs, but not in every browser. So if your browser doesn't support it, then they just decode it using, actually it's asm.Js because this predates WASM, but easily they could convert that to WebAssembly and get a nice speed boost.
Cool, thank you. So will WebAssembly have anything similar to like Ajax, and also what about JSON?
So, sorry, I'm trying to remember if this we were expecting. So I feel like the network functionality that we get today, there's no way we wouldn't have that. We can't not have that in web programs. The question is, to what degree you have to marshal stuff across the layer, across the boundary into the WebAssembly space and back out versus just doing it in your outer program, your outer JavaScript. But the social pressure here is to basically give people as much functionality as you can without causing too much in the way of security risk. And even if there is security risk, that is something that sometimes people wanted to, well, it's unlikely that browsers will want to go into a space where there's security risk, but it's possible that people will just go and recompile things like WebKit to go there independently as their sort of standalone agents. But I think I want a little bit of field, so I think Brad should bring this back home.
Well, I was just gonna say, I mean, certainly currently, because WebAssembly is dependent on that soup of JavaScript around it, we call out to web APIs, and Emscripten has bindings for fetch. That's probably something that we could do. We were actually chatting here a little while back about whether that particular surface could do with a little cleaning up. I believe there's like a fetch and a fetch 2, just because progressively it's acquired more capabilities. It doesn't quite match all of the things you can do in the outside API. You can obviously punch through yourself and do it, but so obviously providing a standard facility in Emscripten that matches the exact things that you can do with a web fetch would make a lot of ergonomic sense, and that's probably something we should put into the tools. But I think the sort of premise of the question misses the point. It's sort of we're reliant on web APIs and we provide sort of the same capabilities, and I would hope that we would be thoughtful about anywhere that we don't sort of match up.
And I think in the limit, what I imagine is the ideal state is we would have anything that's in WebIDL, anything that's defined by nature of adding that and writing it in WebIDL, one should be able to derive the bindings that is exposed to C++ or Rust or whatever language. So it's really, we would just reflect what's in the web APIs more directly into these source languages. So as soon as something gets added as a general web standard, it's available to C++.
Yeah, that's definitely my hope for the host bindings, is that we end up in a place where you just sort of get it for free.
Cool. So Eric, will it be possible to load or save files to use in WebAssembly within browsers?
So yeah, this kind of comes back to the whole tension of the browser is a great tool that a lot of people use on the web for just for browsing the web, but it's also a nice platform that I might want to use for editing my Etsy password file, and yet there's arguably a security difference between those two operations. The sort of standard answer there is just say, well, I'm going to just write it all out to, I forget the name of the protocol, the local storage.
Mm-hmm.
And then, but there was an attempt to have a file writer API that I don't think got too much traction, but maybe it was just premature. It kind of built on the whole blob interface and gave people the ability to write locally actual files rather than dropping them into a sort of an opaque local storage box. But I think in the limit of this, it's really a question of whether there is a band of crazy users who actually want to say, no, I'm going to just go and build my own agents that are just not picking stuff off the web and executing it, just running local programs, and not have to be beholden to the security pragmas that would make just sort of general web browsing safe for people who aren't expert users. So it could happen again, so people could resurrect it. It could happen even within the browser, and it also could be that people just start going in the direction of having standalone independent browser-like tools that leverage all the current web platform, but aren't packaged with a web browser.
Yeah, I would say definitely file storage is an area where I think there's still interesting gaps on the web. I think we need to do more here to enable sort of very rich applications. You know, my pie in the sky dream is I want to be able to run After Effects in the browser, and that's going to require a big jump from where we are to there. It is tricky though, because the web security model is great. It's actually something where people, it's one of the few sort of security models that I think people have sort of an intuitive sense of. I go to this web page, and when I go away, it goes away with caveats about what's on the server. Right now, what we have that's sort of common denominator, right? We have IndexedDB. That's what's offered in each of the browsers, and there's some positive things about IndexedDB, but it would be nice to sometimes be able to grant access to things outside of that sandbox browser storage. And IndexedDB is not perhaps the ideal thing for every kind of storage. It's good for a certain type of data, but if it's tons of video data, you're probably not going to put it there. So I'm hopeful that the WebAssembly folks can go lean on the rest of the platform and get us some better storage APIs that open up some of these possibilities, and maybe explore lower level APIs. There's been a little bit of talk about sort of streaming access to things, or I would like to see something akin to even memory mapping, because ideally you don't want to have copies and all of that, but that'll be an ongoing conversation.
Yeah, and to be clear, except for that one thing of memory mapping, most of these things are pretty much orthogonal to WASM. It's, give us good web APIs and we'll bind to them the same way JavaScript would, and it would help general JavaScript have better access to files. How exactly we do achieve memory map file I/O, maybe that would apply also to array buffers, so it could even that be completely sort of general, but yeah, mostly it's orthogonal.
Yeah, I definitely. It is a good point to emphasize. Definitely, this idea that we want to fix this for the web in general. It isn't particular to WebAssembly. We've got to, right now, regardless of whether you're using WebAssembly, you can't do some of these things quite as nicely as you might like to. And if we can fix that generally, we can fix that for WebAssembly. But yeah, memory mapping, it'll be fun times. There's fun OS differences and all of that. And so
cool. So Luke, if you can just sit back and relax while I read this one out, because it's quite a long one, okay?
Boy.
So the runtime performance of WebAssembly is expected to be around 30% faster than JavaScript, which is quite marginal. I think the main performance benefit would be reduced parse and compile time for WebAssembly. Do you share this opinion? And do you have any expectations around how much faster WebAssembly will be to load and parse? And do you expect browsers to be able to load WebAssembly modules directly in the future?
That sounds like a three-part question.
Yes.
So there's throughputs, load time, and then ES6 module integration. The last one's the easiest one, which is there's a specific feature that's being proposed for that one. So that's the easy one. You'll just be able to say script type equal module source equal foo.wasm, and that should just work when we're done with it all. For the 30% figure, I'm not sure where that came from. I'm pretty sure that's not an official figure.
30% sounds pretty good to me, and for compiler folks, that's not a small win.
30% on a speedometer, a Peacekeeper Octane, or one of these would be distinct. But I think what we see is it's highly variable. So we've seen emulators using 64-bit ints that get a 20x speed up. We've seen extraordinarily carefully hand-tuned JS that hits the perfect sweet spot of the JIT that gets a 0% speed up, and we see everything in between. What we see often is that in the process of converting from an idiomatic JS style into forcing yourself to write, C++ or following all the type discipline of another language like Rust or anything that can generate WebAssembly, it tends to push you towards more efficient patterns that give you the factors speed up. So for fun, one of my coworkers, just to try out the Rust support, ported some of SunSpider tests to WASM, to Rust, and then generated WASM and saw factors speed up. So every single case is going to be different. Sometimes, most of the time isn't even in JS, it's in the DOM, and so it's the actual speed up is bounded by how much time is even in JS to begin with. So that it really will depend on the workload, and I think often we're seeing factors. So that's the throughput. But highly dependent on the workload. For load time, the story is, I think, much cleaner because we have a binary format. We designed this binary format very specifically to decode quickly. So we're talking raw speed of how fast to decode WASM, not to compile it to machine code, just to go through it, comparing that to parsing a bunch of chars. That's generally a 10 to 20x speed up of WASM over JS. Now you have to do something with that after you've decoded it. So the question is, how fast can I produce machine code? And up until now, it's still on release, at least in Firefox, browsers are different. We fully optimize this code because we're coming from sort of a game development mindset where we want all that work done up front so that by the time I'm in my game loop, the first time I run some code, I'm not just compiling a bunch of code and stuttering and all that stuff. But what we recently finished working on is as a first tier JIT for WASM, where up front, we compile to machine code with a much lighter weight process that's 10 to 15 times faster. And with that, we can compile WASM to machine code on the order of 30 to 60 megabytes a second. And when you compare that with the streaming APIs, which allows us to do that while it's being downloaded, we can compile WASM to machine code faster than the network can give us WASM, which means by the time you're done downloading, you're ready to run. And that really fundamentally, I think, changes the story of what it means to load WASM compared to what it is to load JavaScript. And some developers have been pointing out that, when you think of 100K of JavaScript, that's a whole lot. And, there's a big push now to shrink frameworks, shrink the amount of JavaScript you ship because parsing is so slow, especially on like mobile devices. But 100K image is not considered a huge thing because image decoders are so fast. And so really what WASM's doing is allowing you to stop thinking of code like JavaScript and think of it more like, use the metrics, you think of it like an image. So I think the load time will, for some things like web frameworks and other sorts of libraries, really load time will be the high order bit.
I'd like to add to that. I mean, another positive attribute with WebAssembly is the sort of consistency of the performance. One of the issues with JavaScript performance is that you can be swimming along just fine, and then you hit deopt, and then suddenly your performance sort of stutters and drops off. And so WebAssembly generally, although we also are exploring tiering up, has the property that ideally you sort of tier up and sort of converge rather than tier up and then fall down and the sort of thing. So having that precise access to what's underneath and knowing that the types aren't going to change out from under you is a powerful thing. And it's worth mentioning also that we have this nice streaming API surface that we've added for WebAssembly so that you can download it and compile at the same time and express this, and that will dovetail nicely with all of our efforts to if we can keep up with the network speed, then yeah, by the time you're running the program, you'll have already downloaded and compiled it, and it'll be great. And I should say also, we have gone out of our way to try to make the caching story very nice. One nice property of WebAssembly is that potentially you can cache the most optimized version of it. With JavaScript, at least in our engine, it's challenging to sort of to cache the most optimized version. You can cache some versions of it, but to have that fully cached version and to warm that up ahead of time means that you could download an application, get it all ready to go, download the new version potentially in the background, swap it in when it's ready, this sort of thing. These things are kind of possible with JavaScript, but you have to sort of work around the engine to make that tractable to do.
Predictability of performance is a good point. I've heard multiple developers who really care about JS performance say they'll spend a huge amount of time just trying to divine what are the underlying heuristics and the sweet spot they're trying to hit, which of course vary by browser and also vary over time. And so just not having that just be a way you're spending your time, just saying, okay, I just have these predictable primitives is a big time saver.
And I think another nice property is that, you know, in the limit, I think that JavaScript, there's sort of it's such a complicated surface that it's an infinite fountain of cleverness in terms of the kinds of optimizations you might try. Whereas at the end of the day, I think with WebAssembly, there's a set of sort of reasonable things that I think we'll all fairly quickly get to. And then between browsers, I think we can hope that there'll be a fairly consistent level of performance, so that you won't have to wonder now, okay, if it's running in this browser, am I going to suddenly have drastically different performance and have to worry about that in some profound way. There may be differences, but they won't be sort of 20x differences. So.
To some degree, other virtual machines give us some sort of hint about how varied this would be, right? So if we look at VirtualBox or VMware when they're emulating an i86 or emulating a 68XX or something like that, you see fairly consistent behavior between those because there's only a certain number of cool tricks that are really going to pay off, and after that you're kind of going after small potatoes. Is that sort of in line with what you were talking about, Brad?
Yes, yeah, that's the general notion. I think when you're doing things at a lower level, there's fewer dynamic things happening. Although as we delve into managed objects, there's at least more potential for fun. Although my hope there is that we'll be careful to spec things in a way where you'll also be able to reason about the performance.
Excellent, thank you very much. So I've got a question in here, a user question come in. So what do you think will be the biggest hurdle in widespread adoption of WebAssembly?
Well, the one answer is the sort of the hurdle the usual hurdle is that there's a whole lot of deployed browsers out there. Now, this is the boring answer, but the deployed browsers out there that are in large companies that aren't particularly agile is always slowing the web down in terms of evolution. And so there's no reason that will completely change here. I think culture is changing a bit so that in-house system administrators are more willing to give you tooling that's more modern, but that's always going to be a retarding force.
Yeah, I've had the experience of talking to web developers where they're like, well, but I work for a bank, so I have to worry about IE6.
Exactly. Yep.
But on the other hand, we do live in interesting times in terms of security, and so my hope is that we're gradually learning collectively the lesson that it doesn't make sense to be on some ancient dissupported version of a browser, and that there are definite benefits to keeping current.
We could be proactive about this by writing security flaws in so that people have to rev frequently.
I think that there are some ergonomic challenges. I think one of the reasons I'm enthusiastic about host bindings is that I think that will make it easier for folks to incorporate WebAssembly in their application without it being this sort of disruptive thing to inject. I think there are little niceties. I've had folks recently point out, I like to just deploy my framework as one giant JS file, and so the fact that you want to do a separate request for the WebAssembly is a hassle. So there are little things like that might be an obstacle, but my hope is that we'll find our way into a range of frameworks, and you'll be using WebAssembly without even realizing it before you know it. So.
I definitely agreed that being able to use WebAssembly without taking any explicit action will really help adoption. If you can't just kind of get it for free in that way, I think there's a lot of ergonomic issues we need to work on the tool chain to make WASM fit into existing developer workflows a lot more naturally. But that's all work that's doable, and people are starting on that, and I think we can fix that over the next year or two.
I think in the game space where there's a number of middleware companies, the Unities of the world and whatnot, one of the challenges is that some of the content coming from other platforms isn't always a perfect fit for the sort of resource constraints of the web, and so I think there will be a bit of a challenge there to sort of match up user expectations and developer expectations, and figure out how they monetize that content and all of that. So I think there's some challenges around this sort of for lack of a better word, the sort of black box content where it's really just another platform coming to the web. But I think for the content that sort of fits nicely into the web, the more we can have it just be a seamless part of the web as it is now, the more easily we'll see quick adoption.
So the last question of the day. So what's the next milestone in WebAssembly, and when is it going to be reached? Do you want to kick that one off, Brad?
All right. So I think we're coming up on a list of obviously some smaller proposals that are nearing the finish line. We've got multi-return and mem copy, and we've made one mistake already in the format. We had trapping conversions, and we're going to have non-trapping version of those, so that we're going to get that sorted out. So I think that'll be probably the first batch that will come out. But I think the big one is that obviously there are a number of folks that will benefit from threads as a surface. I think that's one that I hope that we'll cross the line on. But I'm also super excited about host binding. So it's all kinds of things coming this year.
Yeah, from my point of view, host bindings will be the next big milestone that's achievable in a short amount of time. Will now enable just a new category of uses of WASM on the web.
Okay.
I honestly have nothing to add.
Okay, perfect.
These guys
I was just giving you that awkward pause there for you to step in if you wanted to. So that concludes our discussion for today. We've had a lot of fantastic user-generated questions, and I'm sorry that we couldn't get them all into this broadcast today, but I've seen that the chat has been very, very active throughout. So I'd like to express a huge thanks to all the in-chat experts, and of course to the three musketeers that have kept you entertained during this AMA today. I really appreciate them. I got another French connection in there. Did you see that? Yeah.
Well done. Bien joué.
Merci, merci. So it goes to say a special thanks to W3C and O'Reilly Media for co-sponsoring this event and helping it bring it all together. And as mentioned before, we will be sending out recording and transcript very, very shortly, as well as other resources from the panelists. So look out for that email. So I hope you all enjoyed this AMA and have a great rest of your day. And thank you very much for all involved, and thank you for attending and giving up your time. Thank you.
Thank you all for attending.
Thank you.
It was fabulous. And thank you for setting this up.
Thank you.